Hello guys and welcome to Aerographed. Today's video was made in collaboration with my friend Tomasz Petrau from the Wind Tunnel project on Instagram and YouTube. So he made this incredible wind tunnel for his scale replica cars and he reached out to me in order to help me make today's video. Therefore, I politely request you to show him much support by either subscribing, liking, following him, and if you can, help him fund his future projects. Thank you very quite much to you, my friend, for reaching out, and the video would not have been the same without you. And before we officially start, I feel obligated to notify you how I am a bloody high school student. Therefore, I do not have an adequate background in engineering. So many of the things I present today could be misinterpreted. So if you notice an error of mine, please do inform me in the comments so I can fix it in the upcoming videos. And the knowledge I present to you today is based on my own research from sources like Kyle Engineers and Chainbear, which I've linked in the description. So these are the 4 latest engine cover designs from Red Bull. Today, we'll be talking about these 2. On the right, we have the RB19, the most dominant F1 car in history. And on the left, we have this year's car, the RB21. So, first off, let's take the RB19. So here, I've drawn 2 distinct airflows. The blue lines represent the clean air flowing on top of the side pods. And the purples, let's call them squiggly lines, is the dirty air from the cockpit. And these 2 distinct airflows are separated by this kind of, let's call it shelf-like structure, which is part of the engine cover. And on the engine cover, we will be running a vortex. Now, why is this vortex important? Let's check this other drawing out. First off, I'm sorry about the confusion with the colors. It's me just being petty about the representation of the flows. It being a bit more easier to follow. That's why I've mixed and matched the colors. So the purple is the clean airflow now around the side pods and around the car's body. The green is still the vortex and blue is now the dirty air. So first off, we can see that the clean air wraps around the side pods and then is sent towards the back of the wing, through the onto the beam wings and towards the hole in the wing, upwards. Then, if we zoom into the engine cover, we can see the vortex and the dirty air. Now, this vortex, as previously mentioned, is quite important. First off, it acts as some kind of adhesive, connecting the air from around the car to the car's body, therefore adding to downforce, helping with maneuverability, giving us more traction, and mitigating understeer. This vortex is also used to clean up and energize this dirty airflow from the cockpit, and this vortex then sends it towards the back of the wing, where it will meet the air from the side pods. So what would happen if we did not generate this vortex? Well, we'd experience something called pressure drag. Now, pressure drag is basically drag which occurs when the air is not properly connected to the body of the car. And let's check this out in more detail. So, we can see that 2 different air pressure zones form. At the front, we have the high pressure zone, and at the back, we have the low pressure zone. And the air, wanting to equalize the pressures between these 2 zones, will start rushing quickly towards the back, pushing the car backwards and acting as some kind of parachute. So this is what I believe to be one of the main things from keeping the RB21 from being the most competitive car on the grid. This is the RB21. And you can see that the engine cover is much more different than the one on the RB19. You will notice the absence of the shelf-like structure in favor of these kind of kidney-shaped protrusions, let's call it that. And Red Bull has first introduced this design in Budapest in 2024 as a higher downforce and better cooling alternative to the side cannons design at the beginning of the season on the RB20. So yeah, after they've introduced this design, their performance has dropped and the car has been noticeably more understeering. We have to take into consideration other parts, like the Venturi tunnels on the car's underside, which generate the most downforce. Therefore, I can't say that the kidneys are the main thing from preventing the car from being the most successful on the grid, because I do not have the adequate information, the adequate numbers or anything from the air tunnel. So keep that in mind. Let's check out what I believe the flow around the RB21 looks like. So I'm sorry about the colors being changed again. This time it's only the dirty air, which is now in cyan. So we can see that part of this dirty air is being forced by the kidneys into the zone where the clean air around the side pods will move towards the diffuser. And what I believe to be happening here is that, of course, Red Bull was trying to get much more downforce with this design, but the overall airflow in this area could be much messier, so it could be decreasing performance rather than improving it. And then, if we look at the top, we can see that much less air is being energized and picked up by the vortex and being sent towards the back of the wing. And since the kidneys have this awkward shape, this could contribute to air separation and the vortex being pointed in some sort of unwanted direction. Let's check out the airflow in the wind tunnel. We will be using the RB19, the RB20, however, with the design that does not have the kidneys, rather the kind of cannons, let's call them, because here we've managed to achieve the cleanest airflow, and we'll be using the RB18. So the RB18 uses the most similar design philosophy, with the shelf being absent and the two airflows mixing, the dirty air from the cockpit and the clean airflow with the from the side pods. Right. And by the time I'm recording this, the RB21 has not yet been released in model form. So yeah, we do not have access to that. Only if we had the DeLorean so we could time travel. This is the RB19. And here we can see the energized airflow going towards the wing. This is the RB20, and here we can truly see everything. The flow around the whole body of the car and the smooth interaction between the cockpit energized air and the side pod air. This is the RB18. Here we can see that the airflow is much more shaky at the meeting point at the wing. And this, I believe, could be caused due to the dirty air from the cockpit meeting the clean air from the side pods. Before we end the video, please do keep in mind that these are scale replicas of real wind tunnels and cars, and that, you know, the results may not be 100% accurate to the real thing. So yeah, thank you very quite much for watching. Thank you very quite much to my friend Tomasz for his incredible wind tunnel. And yeah, that would be the first ever video on Aerographed about aerodynamics. I hope certainly not the last. Thank you very quite much, guys, for watching, and I'll see you in another one. Goodbye.